In this question, we are asked to find the set of values of C for which the curve and the line intersect at two distinct points. And we're given the equation of a curve and a straight line with an unknown component, which they've called C. Now, there's a couple of things that we need to notice, first of all, in the question to help us. So the first is that we're finding a set of values. This tells us that our answer is going to be an inequality and not a single value. We're also told that the curve and the line intersect at two distinct points. So this is where we need to start thinking about the discriminants, because we know that when an equation has two distinct solutions, the discriminant is greater than 0. Now what we're going to do is we're going to start by finding the intersection. So we are going to set our equations equal to each other. They're both equal to y, so I'm going to set them both equal to each other and form myself an equation. Now, I need this equation to be equal to 0. So I need to subtract 4x and c from both sides. So I'm going to do that. So I've now got an equation equal to 0. So I now know that this equation will have two distinct solutions when the discriminant is greater than 0. And because they've used the word distinct, it's greater than and not greater than or equal to, okay, because the points are distinct and not the same. So now I need to identify my value of b, a and c from my equation. So I can see that my value of a is 1, my value of b is 2c minus 4, and my value of c is 4 minus c. So we're going to pop those into our equation. So we said b was equal to 2c minus 4, a was equal to 1, and c was equal to 4 minus c. Now do watch out when you are popping these into your equation, so make sure you've got all your negatives in the right place. What we're now going to do is we're now going to expand and simplify as much as possible. So if I expand my double brackets, I'm going to get 4c squared minus 16c plus 16, and then I'm going to get minus 16 plus 4c is greater than 0. I can make this a little bit more simple, even more so. So I can go 4c squared minus 12c is greater than 0. So what I now need to do is solve this inequality. So I'm going to start by finding the critical values of my equation. So to do that, I am going to factorise. So I'm going to start by factorising the equation by removing 4c, which leaves me c minus 3 in the brackets. Now this tells me that my critical values are going to be 0 and 3. So remembering my inequalities, I'm looking for the inequality being bigger than 0. And if it helps, draw yourself a little sketch of the quadratic here. So here's my 0 and 3, and I'm looking at when the graph is bigger than 0. So I'm looking at these end tails. So I know that c must be less than 0, or c must be greater than 3. So these are my set of values for c for which the curve and the line intersect at two distinct points.